Hi everyone, in this video we are going to cover how to use the data analysis Toolpak to calculate a whole bunch of descriptive statistics about our data. So if you want to follow along, take a minute, pause the video, open up Excel, and we will create some random data to work with. Okay, so I already have Excel open. What I want you to do is go ahead and give your data a title. I'm going to call it data, the most original person ever right here. So the data, just so that this is easy for both of us, I want you to type 1, 2, 3, and then I want you to highlight those 3 cells that you just entered data into. Look for the little green square that's at the bottom. Look for that cursor that's a plus sign, click and drag. And I want you to do this until the last data point says 15, okay? So once you have that, we are now ready to use the data analysis Toolpak. So what we just did in less than 30 seconds was just create data. Usually you'll already have the data that you're working with, so you would not need to know everything that we just did. Okay, so now to use the Toolpak, go to the Data tab, and you should have something called data analysis on the very far right hand side. So if you do not have data analysis on the far right hand side, what you need to do is pause this video and go back to this module that you're currently working in D2L. There's a link above that is another video that shows you how to download the data analysis Toolpak, the add-in. Okay, if you do have it, hopefully you do, go ahead and click data analysis and we'll proceed. Okay, so a dialog box appears and we have a bunch of options. For this class, you already know how to use the histogram tool. You're about to learn how to use the descriptive statistics tool, and there's quite a few more that we'll cover throughout the rest of the semester, but for right now, click on descriptive statistics. These are all in alphabetical order, so just look for descriptive statistics and then click OK. Another dialog box appears, and this is the guy that's going to do all the work. So input range is the first thing that we need to fix. So you can either click right here and start highlighting your data, or you can click the arrow. Yours, this square right here, it might show up as an arrow for you, or it might show up as a grid. On my personal laptop, it's an arrow. At work, it's a grid. Either way, click it. Then this will appear, and this is where we can highlight our data. So click data. I'm clicking the label. And then use the hotkeys that you learned in Chapter 2, Control, Shift, down arrow. That ensures that you've highlighted all of the data. Then click this little box again that has the arrow pointing downward for me, or it might look like a grid for you. Okay, now we've got our data. It says it goes from A1 to A16. Perfect, that's exactly where our data falls. So I make it a habit to always grab my label. If you're like that, then make sure you check mark labels in first row. If you did not grab the label, then go ahead and leave that box unchecked. Then the only other thing that you need to worry about on this dialog box is to check mark summary statistics. Check marking that ensures that all of those descriptive statistics are calculated: mean, median, mode, etc. Okay, so the other thing that I'll mention here is I always let anything that creates a new table, whether it's this kind of raw table or a pivot table, I always allow it to go into a new worksheet. That's just my preference. So I'm going to leave that new worksheet, let that circle be filled in. Okay. If you've gotten this far and you're good to go, click OK. A new sheet should appear, which it did for me. It goes to sheet 2. And again, I'm going to make these columns as wide as they need to be. So again, you can highlight up here. I've highlighted A, B, and then I'm looking for that cursor that has a vertical line and a horizontal line with arrows. So go ahead and double click, and that makes those columns what they need to be. From here, we've got several things. Notice we've got the mean, we've got the median, we've got the mode, okay? And I'm actually going to highlight these for now. You don't have to highlight. I'm just highlighting them because they're ones that we have covered in this chapter. So notice mode, it has a pound, or you might know it as a hashtag n/a. That means that your data does not have a mode. Now, if you go back over to sheet 1, you'll see that under your data, none of these values occur more than once, which is why we don't have a mode. They all occur the same number of times. We've only got 1, 1. We've only got 1, 9. Okay? So I'm going to go back to sheet 2. In addition to that, we also learned about standard deviation, about sample variance, about range, and about count. I'm going to highlight those two. So the range, again, that is just the maximum value here listed as 15 minus the minimum value listed here as 1, which is how they got 14. And then count. Count here is just your sample size. So we have a sample size of 15 observations. Okay? So these, you can calculate all of these sample statistics. So I want to emphasize the word sample here because mean, median, mode, standard deviation, sample variance, range, and count, these are all sample statistics. Okay? I do not want you to confuse those with population parameters, which you'll cover on the next page in D2L. Okay, so these are sample statistics. Okay, now we have 2 additional measures of variation that are not calculated when you use this data analysis Toolpak. In fact, I mentioned in D2L that you need to put those formulas to memory. So let's see if you guys can remember them, maybe even before I write this down as you're watching this video. So one of them is coefficient of variation. I'm just going to type CV for short, okay? And actually, let me take a step back. Let us copy this data. So copy everything, this table that was created. So highlight all of it, and then hit Control-C, go back to sheet 1, and I want us to paste it here. Hit Control-V, okay? So, now, again, we have 2 additional measures of variation that do not have Excel formulas, and the Data Analysis Toolpak doesn't cover them. They are coefficient of variation and z-score. So, let's type out coefficient of variation, or CV for short, and then right underneath of that, we're going to calculate it. So, if you remember what the formula is, it is equals standard deviation. So I'm clicking the cell that has our standard deviation, divided by the cell that has our mean. Okay. So you can right now multiply that by 100 if you want. And in fact, if you do that, then you will need to put parentheses around it, times 100, because remember, coefficient of variation is a percentage. You can do it that way, or, and I'm just going to type that formula again in the cell below it, okay? So equals standard deviation divided by the mean. If you don't want to bother with the parentheses and multiplied by 100, you can hit enter. Notice it's the same number, but it's in decimal form. If you're on the Home tab, if you look in the middle, there is a percent sign. If you click percent, it will change the style in which that number is showing to you. So, and I'm going to give us a couple more decimal places here so that you can see that these numbers are the exact same, whether you put the parentheses times 100 or if you leave it and just change the formatting. So using that percent sign, okay? So the other one, the other guy, the other formula you need to care about is for z-score. Now, and actually I'm going to write this up here, z-score. And if you remember from your notes, z-score, we will calculate it for every single observation in your data. So remember, we have 15 observations in our data. That means that we should calculate 15 different z-scores. So that's what we're about to do, except we're not going to do it by hand. We're going to let Excel do the math for us. That way, hopefully there's no mistakes. So the formula for z-score, we are going to type equals. And here, make sure you put parentheses because the order of operations will bite us if we do not use them. So put an open parentheses. And then this formula is equals xi. So for us, that's that first data point. Technically, it's x1 because it's, again, the first observation. Minus the mean, x bar. So I'm going to go over here and click this cell. When I'm doing that, I am going to lock that cell reference. So if you're on a desktop, you can just hit F4. If you're on your personal laptop, you might need to hit the function button and then hit F4, which I do because I'm using a laptop right now. Then close the parentheses. That's just the numerator of our formula for z-score. We also need to include the denominator, so divided by, and the denominator is standard deviation. So I'm going to click the cell that has the value for the standard deviation. And again, I'm going to lock that cell reference. So again, function F4 for me. It could just be F4 for you if you're on a desktop computer. Excuse me. Okay. Then go ahead and hit OK. Right? Hit enter. So we locked those cell references. You can see the formula again up here in this bar, this editing bar. So we locked the mean and the standard deviation. We did that because for every single calculation of the z-score, regardless of if it's for observation 1, observation 5, observation 14, all of your data, if you want to calculate the z-score, all of them use the same mean and the same standard deviation, which is why we locked the cell references. So instead of typing that formula 14 more times, we are just going to click and drag. Lazy way out. That's me. I'm always looking for the quickest way to calculate things. Okay, so we've got now all of the z-scores that correspond with our raw data. So let's take a look at the first z-score that shows up. This is with respect to observation 1. Notice it is negative. That means that our observation 1, it takes on the value 1, which means if you look at the z-score, it's negative. It is less than the mean. Okay, so that is why your z-score is negative. In fact, what we know is that first observation is in fact 1.57 standard deviations below the mean. That's what the z-score is telling you. It's telling you whether or not that observation is above or below the mean. That's whether it's positive or negative. In addition to that, it tells you how far away it is from the mean, measured in standard deviations. So if you go down here to 0.223607, this corresponds with observation 9 that takes on the value 9. Notice its z-score is positive 0.22, blah, 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 more numbers, right? So what this means is that observation of 9 is 0.22 standard deviations above the mean. And in fact, it is. If you look at that observation, it's 9, it is in fact above the mean. And it's really not that far above the mean. 8 to 9 is not very far, especially when your standard deviation is 4.47. Okay. So, this video covered how to use the data analysis Toolpak to calculate a variety of sample statistics. Make sure you know it's sample statistics. In addition to that, I showed you how to calculate coefficient of variation and z-score in Excel using the mathematical formulas you learned in this chapter.